and welcome to science class. Today, we're starting a new topic. We're going to be learning about the periodic table and the elements that make up the periodic table. So, to start off, let's discuss what is matter. Now, matter is anything that takes up space and has a mass. So, for instance, these gloves are made of matter. This bottle is made up of matter. This tray is made up of matter. I am made up of matter, and you are made up of matter. Therefore, we all matter. Yeah, I know, that was bad. It's okay. Matter is made up of basic building blocks called elements. Now, matter can be in solid form, like these gloves. It can be in liquid form, like this hydrochloric acid that I have right here. It can be a gas, like the gas trapped inside of this bottle right here. It's a mixture of nitrogen, oxygen, and other gases. Or it could be plasma. Now, I don't have a sample of plasma on hand because you see, plasma only really happens with really hot temperatures, like with lasers and on the sun, and I don't have those on hand with me. So you'll just have to take my word for it that plasma exists. Now, I had mentioned that matter is made up of building blocks called elements. Now, elements are shown on the periodic table, and we know that there are 118 different elements. Each of those elements represents an atom, a specific kind of atom. And atoms are very small particles. They're so small that you can't see them at all. In fact, no human has ever seen an atom, ever. If we take a look at this paper, and you see how thin that is? It's pretty thin. This paper is thin to our eyes, but to the eyes of an atom, it is 1,000, it is 1,000,000 atoms tall with just thickness. Now, an atom is the smallest particle of an element that still shares the same chemical properties as the element that you can see and feel and touch, that kind of stuff. Atoms are made up of 3 smaller particles that do not share the same chemical characteristics as the rest of the atom. The first one is the proton. Proton is a positively charged particle. Then we have the neutron, and the neutron is a neutral charged particle. Last but not least, we have the electron. The electron is a negatively charged particle, and it zips around the center that houses the protons and the neutrons together, which is called the nucleus. So we know that atoms exist because some very smart scientists did a bunch of experiments and they proved that atoms exist and that they're made up of these particles. And in fact, we actually know that the particles like the proton and the neutron and the electron are made up of even smaller particles, and those particles are even made up of smaller particles. Fun fact, the smallest particle that we know that exists is called a quark. Now, atoms are incredibly small, but scientists have figured out what they look like, or at least what they could look like. There's an entire history actually showing the different models of atoms throughout the years. Started off with a very simplified model, and now it's become very intricate and very complex. Now, the reason why we have these models is because these scientists have run a bunch of tests, so they know how these different particles, the neutrons, the protons, and the electrons, how they interact with each other and how they move around and what they do. And they have a pretty good idea of where in space they kind of lie. So here is an example of an atom. This is the model that we're going to be seeing. You're going to be seeing the nucleus with the protons and the neutrons in the middle, and you're going to be seeing these, what we call orbitals or electron rings that kind of circle around. Now, Remember, this is just like a two-dimensional plane here. This is like what you would see on a flat piece of paper. In reality, atoms are three-dimensional, so really they can rotate and the electrons are going to be zipping around all over the place. So we have this model, it's called the Rutherford-Bohr model. It's not the most accurate model of an atom, but it is accurate enough for us to understand how atoms work and how chemical bonds are formed and all that fun stuff that we're going to be learning about. So now that we've talked a little bit about atoms and a little bit about matter and a little bit about elements, which are essentially atoms, let's move on to looking at the periodic table. Now, looking at the table, there is a lot of information that you can glean from it. First off, this particular table is color-coded. So each particular type of element has been grouped or has been categorized into different kinds of subcategories, essentially. We can also learn a lot about how chemicals will interact with each other, how elements will interact with each other and form chemical bonds, just by looking at where it is in the periodic table. Now, I want to bring your attention to this dark pink staircase close to the right-hand side of the periodic table. My left, your right. This staircase right here. This staircase is a dividing line. You see, everything on this side of the staircase is considered to be a metal. Now, metals in general have a couple of characteristics that can be just grouped together. For instance, they will conduct heat and electricity extremely well. They are also pretty malleable, like Play-Doh. I mean, obviously, we aren't strong enough to play with steel and other things like iron and stuff like Play-Doh, but they do have malleable qualities to them. They're also extremely ductile, meaning that they can be pulled and they will stretch. Now, another interesting thing about metals in particular is that metals will react with acids. And they're often usually solid at room temperature. I'm looking at you, Mercury. Mercury's not solid at room temperature, but the rest are. Now, if we take a look at the actual elements that sit on the staircase, so the ones in bright pink here, these ones, those are what we call metalloids. Now, metalloids are kind of similar to metals in the fact that most of them are solid at room temperature. They can conduct heat and electricity, though not as well as metals. They are malleable to a certain extent, but they are different from metals because they also share some properties with non-metals. Now, non-metals are the elements on this side of the staircase, on the right side of the staircase. So that includes all of these guys. But there's one element on this side, and that's hydrogen. Hydrogen is also considered to be a non-metal. Hydrogen is the outlier. It just, the way it falls on the periodic table, just take my word for it. Hydrogen is a non-metal. So it has characteristics that belong to this side right here. Now, non-metals are usually a gas at room temperature. They do not conduct heat, they do not conduct electricity, and they do not react with acid. If they are solid, because some of them are solid at room temperature, these solids can be crushed easily to make powders. Take carbon, for instance. Carbon is basically coal. Coal is basically carbon. Almost everything that's living or was once living is made up of carbon. And when you take coal, it's actually quite easy to crush it in your hands. It's not like metal where you have to heat it up and then you have to bang it with a hammer to get it to do anything. It's very easy to crush. So that's how we categorize large groups of the periodic table. We have the metals, excluding hydrogen. We have the metalloids, that are the staircase. And then we have the nonmetals, which includes hydrogen. So this has been a look at matter, atoms, and elements and how we organize all of the elements in the periodic table. So I will see you next time when we start talking about the different groups and periods of the periodic table. So, until then, bye!